relationship between R and C and plug it in back over here to the area. So area will be, let's move to the next table. Where are we? Back corner? We'll go back corner and then we'll come back through. So how would this equation be rewritten?
A equals pi.
Pi?
And then for R, you substitute C over 2 pi.
C over 2 pi? And then square that, because it's supposed to be R squared, right? Now you have an equation that relates A and C together, don't you? So what I'll do next is I'll try and clean it up a little bit, because I see some constants in here, right? You square a fraction, you square the top and bottom. So I've got A equals pi times, the top squared is C squared, the bottom squared is 4 pi squared. All right, square 2, square pi. And then can't I like move the 4 out here and the pi squared underneath? That's the same thing? What can I do with the pi's? You can cancel one of the pi's? I forgot the squared, sorry. Yeah, the C is on top, right? I could put the C on top or on the outside. Why am I choosing to put the C out here? Someone tell me why I'm doing that.
We're going to solve for C.
I'm not solve for C.
We're
We're going to take the derivative, right? And 1 over 4 pi is a constant. It's just going to come along for the ride. If I put the C squared on top, then you might be starting to think quotient rule, and you don't need all that. This is just a number out in front of C squared. And derivative of C squared is going to be easy for us to get. Make sense? I think I'm at derivative time. Okay. So derivative of this with respect to time. What's derivative of the left side? dA dt. Right? Remember, don't plug anything in yet, right? You don't plug any numbers in until after the derivative. One over 4 pi comes along for the ride. What's the derivative of c squared? 2c dc dt. Are you happy with everything you see in there?
Yes.
You sure you're happy with everything you see in there?
Yeah.
dA dt, was that given to us or did we want that? That was given to us. 1 over 4 pi is a constant. 2 is a constant. C, were we given the circumference of this circle? But we weren't given it directly, right? But we can actually find it now because now we're allowed to fix everything in time. And if we know the radius is fixed at, what, 4? What was it?
Yeah.
It was 4? If I know the radius of a circle, I know its circumference. So I will be able to get C. It's going to take a little work. And dc dt is what I wanted to know, isn't it? So I am actually happy to see everything here. So I'm going to write down here, you know, that's all good. But I need C at the instant in time. So at the instant in time, my radius was 4. Circumference is 2 pi r, which for us would be 2 pi times 4, which would be 8 pi, wouldn't it? So would you all like to do this with me, including the units the whole time, or you just want to do the units at the end? Units at the end? You include the unit? Okay. So why don't you include the units and see if you match up with our answer. What's dA dt for us?
40 square.
40 square feet per second. So I'm just going to put 40 there. Equals 1 over 4 pi, but then times 2. 1 over 4 pi times 2 times c. C was 8 pi. And then times dc dt, which we don't know, right? That's what we want to know? So we'll just put dc dt. And this is now an equation that we're just going to solve for this. Right? We're going to try and isolate that by itself on one side of the equation. So I think good things happen here, right? Pi, pi, cancel. What, 16 over 4 is 4? So we get 40 equals 4 times dc dt, which means 10 equals dc dt. Now the units. dc dt equals 10 what? So, what's that? What the units are here. Can you tell me what the units of time are? What's the unit of time? Seconds, because the whole problem is in seconds. How do we measure the circumference of something? Circumference.
Feet?
Is that feet, or is it feet squared or feet cubed?
Feet squared.
It's the measurement around something, right? So if I take the measurement around something, it's like a string. I take the string off and I lay it out and I stretch it tight. It's just the length, isn't it? So it's the unit to the first power. So this is just feet per second. Is that what you got? Did you do it the other way? No?
I included the units.
The whole time?
Yeah.
Did you get the same answer?
I
Have you canceled them all out?
The feet would have to cancel out somewhere.
Yeah.
Both would have to-
I'll do this one with the units just one more time. This is the last time I'll do it, just so we can see how it would work, okay? If that helps out later on in a different class. So I'm going to rewrite this right here. It's 40, and then it was square feet, right, per 1 second. I'm going to just do it. I'm going to go real crazy here and do it that way. And then over here, 1 over 4 pi times 2 times, what was that, circumference? Circumference was measured in feet. So 8 pi feet, right? And then times dc dt. Yeah, so this whole thing becomes a 4, right? And you divide both sides by 4 feet. So when you divide this side by 4 feet, one of the foots cancels and you get the 10 feet per second. Where's my coffee?
It's right there.
Oh, there it is. I'm tired, man. I'm real tired today. I've got this weird thing in my eye. Like my eye is all red right here. It's weird. Anybody ever had that before? Just like wake up and then got like all this red, like it's not itchy. I don't have pink eye or anything, but
Do you ever have PRK or LASIK? I get that a lot, but I only got it since I had surgery.
You saw that today? I got some in my eyes.
no, that's. I wasn't doing that. I really did. I have something you can see. It's like all red. It's weird. All right.
Like to say that, like, you actually get the answers, whatever you're looking for, is pretty much what the units is going to be.
Yeah.
So you don't really.
You ready? Do you remember when we wrote down what we wanted and we said dc dt is what we want?
Yeah.
I can already tell you the answer is going to be in feet per second
Yeah.
because it's right there. Yeah. Imagine the same sort of problem with a sphere. What would change? All your equations would change, right? You've got volume now, you've got area of a sphere, surface area. You've got a lot of different equations, but everything would be the same sort of principle, wouldn't it? You write down what you're given, what you want, you find an equation, you relate the two, you differentiate, you plug in. Okay, so I'm going to skip a surface problem. I'm going to allow you to maybe look at that on the video. I'm going to get to one that's a little more interesting. classic Cal 1 related rate problem. Yes,
You asked order and a sphere on the test.
I could, yeah. Yeah. I mean, if you want, there's homework problems that involve it, and if you have trouble with it, then get with me. What I want you to do is I want you to try and tackle a sphere problem on your own without me showing you a sphere problem. No, because that's the whole idea behind the related rate problems is that every problem is so different. What you have to understand is the fundamentals of it. Like you set up what you're given, you set up what you want, you set up your pictures, you create the relationship. This is not just let me show you how to do a sphere problem, now you go do a sphere problem. It's more than that. It's conceptual.
Are they all going to be geometric?
Not every problem is geometric. And in fact, the geometry we just had was pretty boring. This next problem is going to incorporate a little more geometry. So the problem is this. Let me write down the problem first. A plane, this, like I said, is a classic problem. A plane flying horizontally at 600 miles per hour and 2 miles high. A plane, is flying horizontally at 600 miles per hour and is 2 miles high. Now we are going to assume for the sake of this problem that the Earth is flat. If you want to start putting the curvature of the Earth into this, the problem becomes much more complicated. I don't think you want to deal with that at this point, right? This is only our third example. But you could incorporate the curvature of the Earth into a problem like this. We won't. Is that okay with you?
Yeah.
All right. All right, so you've got this plane flying horizontally. It's 2 miles high. It's going 600 miles per hour, right? A radar station on the ground is tracking the plane. At the moment the plane is 5 miles from the radar, how fast is the distance between them closing? Everybody understand the question? Do you see a picture yet in your mind? Or got a plane flying horizontally? It's 2 miles off the ground, right? There's a radar station on the ground, right? It's watching the plane go over, tracking it. At the moment the plane is 5 miles from the radar station, the distance, what we want to know is how fast the distance between them is closing.
And it's still 2 miles high, right? It's just
2 miles high the whole time. Yep. It's coming at them. So here, let me show you this. Let's say here's the ground, and I'm a guy standing here, right? And there's a plane that's also on ground level, right? And that plane is traveling at 600 miles per hour coming towards me. right? What is the rate that how fast is the distance between us closing? 600 miles per hour. Because we're in the same horizontal plane, aren't we? The same horizontal line. But if you move this man down here, then the distance between them is not closing at 600 miles per hour. In fact, it's different depending on where the plane is. If the plane's way out here, the rate which they're closing is different than the rate here. Maybe or maybe not, do you think?
Well, because you have the hypotenuse.
It's the like hypotenuse of a triangle, right? Okay, does everyone see the picture? Let's draw our own pictures. How about that? Draw our own pictures. We want a picture at the, let's see, where were we? Did you guys answer last one? Yes? Okay. Lena, we're at your table. What am I going to do here? Give me the things that I said you should do for all the problems.
Picture.
Okay, general picture, then instant in time, and then, well, those are the two pictures. What else do we want? The given and what we want, right? And when we want it. That's going to be pretty much the template for every problem. I'm not guaranteeing you this will always work, but this is going to work most of the time, all right? 95 to 98% of the time. So let's continue. General picture. What do you want me to draw? How about the ground? Yeah. Okay. Draw the ground.
Little radar station.
Little radar station. I always tell my classes, don't be jealous of my artistic abilities and stuff like that, okay? I understand, it's just Cal 1, you're not an artist like me, so, kidding. That's my radar station. And we're assuming it's on the ground, so we're assuming that it's actually 0 tall, like it's got no height. If it actually had some height, we would have to incorporate that into our problem, but we're assuming it's really just a point on the ground. What else goes in my general picture? Plane. What would you like? C-130, C-5, F-14? What do you want? I'll just do my standard plane. There's my standard plane. It's a huge vertical stabilizer on that one. It's a jet.
Could it be like triangle instead of like an airplane with a radar?
Yes, you don't have to. Like I said, if you don't like my, if you can't draw an airplane, Alina, it's okay. Just draw a point. Anything else about this picture? The height is 2 miles. Now, is that a general situation or instant?
General.
It's both, right? Like the height of the plane isn't changing. So that is a constant. That you never have to assign a variable to. So I can actually label the height here 2 miles, right? And this plane is moving, right? So let me try and give it some motion. So I'm going to imagine like it's moving like this, right? Going that way. I'm going to throw a little more into this because this is my picture, right? That plane is moving at a rate of what? 600 miles per hour. Now that's not necessarily like a distance or anything, right? It's just trying to represent how fast that there's motion in this picture, right? I think maybe that's good enough for now. I don't know. The distance between them?
Yeah.
Why do I want to write the distance between them? Because it's changing, and that's what I want to find, right? So maybe I label that now. I was going to get to that, and what I was going to do is I'm going to say, what are we given, what do we want, and maybe that would lead us to that. But if you see that now, it would be important for us to actually draw a line that would represent the distance between the plane and the radar station. And that distance changes, doesn't it? So I cannot fix that in my general picture. If that plane's, way out there, that hypotenuse-looking thing is way real long, and as it gets, well, if it's right overhead, it's what? It's 2, right? But it's changing. So if it's changing, I can't fix it. It's going to be h. I'm going to label it h. For hypotenuse, you could label it anything you want. I would just avoid t, because you're going to use t for time, right?
Would you have an angle that's changing?
You do have an angle. That's the next. That was the next example I was going to give you. Separate problem. Same question, same situation, plane flying, but instead of trying to figure out how fast this distance is changing, to find out how rapidly the angle is changing.
So you wouldn't need to know the angle to figure out.
You won't need it. No. We good? All right. The only difference between that picture and this picture is that h is what? 5. And this height is actually still what? 2. And it creates a right triangle. And I think that's what we were kind of seeing already, that we have a right triangle. So let me construct that right triangle over here too. You see how my picture is developing as I'm thinking through it? Like initially maybe I wasn't drawing a right triangle, but I want to draw a right triangle because I know that this side is 2. So that's good information to have. If I'm looking for the hypotenuse and I know one of the sides, that's good, right? How about what we're given? What are we given? The speed at which the plane, the speed is a derivative, yes?
When you add the 600 miles per hour in your instant picture?
Exactly. Where do you put it? It's not a quantity on the triangle, is it? Would you agree? Like I can't say that's 600. Like it's not, because it's an actual speed of something. Now it's going to come into play. Trust me, it's going to come into play, but that's part of what we need to figure out is how does it come into play. So we're given those 600 miles per hour. So I'm going to write 600 miles per hour, like that. We know that this is a speed, right? We know it's a derivative then. It's going to be d something dt, right? D what, though? D what? V? dm? dh?
Wouldn't it be
wait,
V?
I don't,
Is it h? No, because h is this, right? How fast that's changing? That's what we want to know, right? It's not 600.
Yeah.
So it's not h. It's something else. It can be anything you want it to be, okay? Call it whatever you want it to be. I'm going to call it x, right? dx dt. But here's a problem. Our picture doesn't have x in it, right? Our picture doesn't have x, or does it?
Yeah, X is at the bottom.
Now, we drew this triangle this way, right? What if I had drawn the triangle this way? Then wouldn't the distance from here to here, couldn't I call that distance x? And then wouldn't 600 miles per hour represent how fast x is changing? Yes? Do you agree or not? If this point is not moving, and this point is the plane, how fast is that point coming towards this point? 600 miles per hour. That means x is changing at a rate of 600 miles per hour. Yeah? But if I call that side x, I can call this side x too. Right? But there's one other subtle thing. Is x getting larger or smaller in my picture?
Smaller.
It's getting smaller, which means it's a negative rate of change, which means I need to put a negative here. Because in my picture, x is shrinking, not growing, right? So I should put a negative change for x. Understand that? What is it that I want? I want dH dt. Is h in my picture? Absolutely. When is it that I want it? At 5? At what 5? At h equals 5. Okay, again, we need to specify what it is at moment in time, what variable it is that we know. H is in my picture. Good to go. I think I'm good to go. Do you think I'm good to go? Yes? Where are we at? We here? You guys have a day off if you want. But I think y'all can answer it. What do I go for now? If I've got all my given information, I'm pretty happy with my pictures, what's the next phase?
Find an equation that has both
Relating
x and h.
x and h. We need to find an equation that relates x to h. That's what we need now. All this artistic work on now. Oh, well. Okay. I need an equation relating x to h. And what is it? I just erased my triangle. Pythagorean equation, right? We had a right triangle, a squared plus b squared is c squared. So that would have been for us x squared plus 2 squared is h squared. Go back and look at your picture, right? That's what we had from our general picture, right? Our general picture. Derivative time. What is the derivative of that with respect to time? So 2x times dx dt. Don't forget, you need the dx dt, don't you? It's not with respect to x, so the derivative is not just 2x. What about the next one? 0, right? 2 squared is 4, derivative of 4 is 0. So there's no contribution from that at all. Equals 2h dh dt. Plug and chug, is that what I said? Do you know what x is, though, at the moment in time? At this instant? No, go back to your instant picture. This is all we had, right? We had 2, we had 5, right? We could, well, that would get us angles, though. Wasn't this side x? Isn't x squared plus 2 squared equal to 5 squared? So you can actually get x from the Pythagorean from this at the instant in time you can, right? So I'm going to be able to get x. dx dt. Yes, I know it. H, do I know h at the instant in time? 5. dh dt is what I want to find. So everything I have is here, except I have a little work to do to get x. Do you agree? All right. So I'm going to get x now. Or I said earlier I need x. So I use this picture. What is that, 25 minus 4? 21? Root 21. Plus or minus, but x is the length of the side of this, so it's not negative. Root 21? So I'm ready to write this down. Plug everything in. Oh, yeah, check this out. 2's are gone. I don't need them, right? Divide both sides by 2. You don't need those. Right? I could just get rid of those. All right, x is root 21. dx dt, negative 600 equals h. 5 times dh dt is what I wanted to find. Let's break out a calculator for this one.
You can simplify the left side.
Yeah.
Divide that by 5.
Let me see here. Come on. What am I doing? Pressing the wrong button. So the square root of 21 times negative 600, I get negative 2,749.545. Then I'm going to divide that by 5. Divide both sides by 5. And I get negative 549.91 equals dH dt. What is the unit, or what are the units, or what's the unit going to be there for that? H is what, that hypotenuse, which was a length, wasn't it? What are we measuring lengths in here? Miles. And then time in this problem was hours. So MPH. Negative 549.91 miles per hour. Not quite 600, right? Why is it negative? It's closing in, so it's coming towards me, so we're looking at as a negative speed. Once the plane goes past me and is 5 miles away from me on the other side, then what? Once it's gone over me, I'm dead, it dropped a bomb, I'm dead. No. So over there, it's 5 miles. Now that would be that number, but positive, because it's moving away. So dx dt would be positive 600 instead of negative. All right, well, I don't think we have time for another one. Let me see the book real quick. I'm just going to give you a couple of problems to look at. You circled the ones that are homework? Okay, thank you.
It's, yeah, that's the hardest part. Like the circle one? Where we're like,
Here are the ones from the homework that I think you should take a look at now. 1 through 6, sorry. 1 through 6. 11, 13. And if you're really brave, 14. We have more to do here, okay? There's more that I need to show you, because you really only have had, what, 3 examples? Is 3? But those problems, with what I've given you today, at least those, you should be able to at least start to attack. All right? No, because I want you to work on it, but I won't take it as a quiz grade. I'd rather have questions when we start class. Okay? All right, everyone have a good weekend. When's our test? 20th?